Hello everyone and welcome to another problem solving section with Special Maths Academy. In this video, we'll be looking at the fourth problem from the first round of the Special Maths Contest 2024 edition. And let's dive straight into the problem. So it says, let PQRS be a convex quadrilateral such that PQ equals to RS. Such that PQ is parallel to RS. So that symbol there is for parallel lines. And QR equals to PS and angle RPS equals 90 degrees. So which are the following are possible except, so we have to pay close attention to this. So the following are possible except. So let's look at this. So don't mind my diagram. So let's look at PQ, RS. Okay. So we have PQ is parallel to RS and PS is equals to QR. Okay. And RPS is 90 degrees. Okay. So the following are possible except. So looking at this, so there are two possibilities for PQRS. Okay. So just looking at this. So it's either it's a parallelogram or it's an isosceles trapezium. But if looking at this problem, we're trying to eliminate some possibilities. So something that should come to mind is to try to construct. So based on looking at how this behave, is some of the options. So PQ being equals to PS, PQ being equals to RS, and then this 2PQ being equals to RS and 2PS being equals to RS. These first four possibilities hint at us looking at half of a regular hexagon. Okay, so if you have a hexagon, okay, so now since it's regular, it means it's cyclic. So I'll just try and draw a circle. And then if you look at half of this hexagon, so let's look at this. So since it's a regular hexagon, it's cyclic, it means uh, the center of the circle is somewhere along this line, and then we can uh, bring in the second radius of this hexagon. So all these are equal to regular hexagon. And then something we can look at quickly is that since this is a regular hexagon, all these are actually going to be equilateral triangles. Okay. All these will be equilateral triangles. And of course, since this is the diameter, it means if we look at this angle, so let me use a different color here. Let me say red. So if this red angle here is going to be 90 degrees. Okay, so we can have something like this PQRS. So I'll just call this point X and Y. So basically, in this diagram on the right here, we have that PQRYXS, a regular hexagon. Okay. Then, okay, so what remains for us to see, to get is that we want this parallel, uh, we want that parallel condition to hold as well. Okay, so we can quickly get that. So recall that since the regular hexagon, all the angles in the regular hexagon are 120 degrees. So it means this angle here, RPQ, is going to be 120 minus 90 degrees. So that's 30 degrees. Okay. And then we can also quickly get that this angle here, okay, remember I said these are equilateral triangles. Okay. So this angle here, we can quickly get it to be 60 degrees. And then we have a right angle triangle here. So this angle here is also going to be 30 degrees. So this shows that these two lines are parallel. So it means if you consider half of a regular hexagon, we can quickly see that, okay, it's possible to have PQ being equal to PS. So we can have PQ being equal to PS, of course, regular hexagon. We can have PQ being equal to RS, uh, PQ being equals to RS. That's in the case of it being a parallelogram. So parallelogram, I would give a scenario where this holds for a parallelogram. And then this so option C and option D, so uh uh half of a regular hexagon, you can see this hold. And then option B is a parallelogram. So to see the case of a parallelogram, we can construct something. Okay. So if we start from PRS, the um, right angle triangle, and then we just construct this line, make it parallel to this, and then we make a oh, we make a second triangle, so PQR, such that um, it's congruent to the triangle PRS, so we want this to be 90 degrees as well, basically. So there are a lot of ways we can do this. So we can basically copy this triangle, create a second congruent triangle and append it so that we create a parallelogram. So we know prior to a parallelogram, opposite sides are equal. So uh, this this is a possibility. So one is a parallelogram. But then for the first option, option A, option C, and option D, we have that if you consider, the isosceles trapezium that arises from half of a regular hexagon, we get those those possibilities occurring. So now the last option is where we have a problem. So basically we're looking at is it possible for PS to be equal to RS? So is it possible for PS to be equal to RS? So if you look at the triangle PRS, it's a right angle triangle. So since it's a right angle triangle, it means the hypotenuse is the bigger side. So it's bigger than the other sides of this triangle, in this case, PS. So this is where we have a contradiction. Okay. So option E is not possible. But if you look at the other options, so option B, a parallelogram satisfies that. Option A, C, D, half of a regular hexagon satisfies that. And so yeah, that'll be all for this video. So the key details, so important fact is that all regular polygons are cyclic. So I just used that fact immediately when I was analyzing the regular hexagon. And then we can bring in the circumcenter of the regular hexagon, and so you can quickly get that this divides the regular hexagon into equilateral triangles. When you see that, so each of these the angle at the center, so at the circumcenter of the regular polygon, is divided equally. So each of these angles here will be 60 degrees, 60 degrees. And since each of the angles at that center are 60 degrees, and we have, the radii all being equal, so you have isosceles triangles with the angle in between 60 degrees. So this makes each of those triangles equilateral. So just reiterating what we got in the video. Okay, so that'll be all for this video. Please, if you haven't subscribed, please subscribe. Don't forget to like, share, and comment. And see you in the next video. Goodbye.